Good morning. Welcome back to the course. In this lecture, we will discuss green quality function deployment. What is quality function deployment? Customers have some needs. They have certain voices. Those voices are to be translated into the productions or the managers or the production manager's requirement. So, quality function deployment is a technique that translates the customer's voices to the manufacturer's specifications. How this happen, we will see. We will discuss green QFD. How can we translate the green or ecological requirements or the voices of the customer to the manufacturer's specifications? So, QFD is a structured approach that defines the customer needs or requirements and translate them into specific plans. It helps to produce products to meet the requirements those customers has set. So, we have a term known as voice of customer, which I will take first in the contents. Voice of customer is a term to describe these stated and unstated customer needs or requirements. The voice of customer is captured in a variety of ways: direct discussions, interviews. There are certain kinds of data I will discuss, primary or secondary data, the data that is already available, that is secondary data from the catalogs, from feedback forms, all those things, those are secondary data which are already available. Primary data is the one that is generated. We conduct interviews, we ask them to fill questionnaires, those things we will discuss. So, voice of customer is translated to the manufacturer's requirement. The first thing is to identify what is the voice of the customer, or what does the customer need and how we will meet that. What does customer need and how we will meet that? These are the two questions. Next is QFD we will discuss. We will discuss what is house of quality. House of quality is one of the major techniques to employ QFD. Then we will discuss product design specifications. Then I will show you some examples on QFD. Then we will see green QFD. So, voice of customer, the focal conviction of the item improvement process is that items ought to reflect the customer's needs and tastes. A standout amongst the most critical parts of the product development cycle at this point is to comprehend or to find out the gain from the customer. The reasons the customer would purchase your product are multiple. They would like to have product that is simple to utilize, product that is giving a good performance, that is having a great quality, low cost, products those are green. So, there are certain reasons for which the customer would buy the product. Reasons customers will buy your product: low cost, whatever the perception is with the customer, in that low cost has to be there. The product has to be durable, then ease of use. These are the product characteristics which I discussed when I discussed the product characteristics. So, what is voice of customer telling us here? In watching the customer's purchasing conduct, it has been discovered that their choices about items depend on properties that can be masterminded into 8 classifications as follows. Number 1 is cost, number 2 is availability, packaging, performance, then usability, affirmations, life cycle cost, and social benchmarks. Cost. The cost of the item can be utilized to pick up an upper hand. The cost is the first question the customer would ask: could I afford this item? That is the question that he will ask. Availability. Is it available locally, or do I have to get it from some global market, or can I discover it? That is availability. An item ought to be accessible when and where the potential customers need it. Packaging. Packaging is the thing that the customers sees, and much it impacts the purchaser's determination. So does the packaging look appealing? This is a question that customer might ask himself. Performance. Execution should specifically fulfill the customer's most vital necessities. So performance is, can I do what I expect from this product? I will discuss Kano's model. There are certain expectors, exciters, those things are there. We will just come to that. Usability. The item ought to be anything but difficult to utilize and work. It can be anything but difficult to utilize and work item is not desirable. Simple to utilize item might be ideal to one that has more features and abilities. So the question here that can be asked is, do I know how to utilize the item? What is the ease of operation? How easy is the item to use? What is the human comfort involved in it? All those questions. Affirmations. A notoriety for sturdiness, unwavering quality and support will impact many customers' decisions. Affirmations is the durability. Will it last? How long would it last? Life cycle costs. Life cycle costs, an item whose aggregate cost of upkeep, repairs, vitality, utilized supplies and downtime is impressively not as much as comparable items may have a focused edge. That is life cycle cost. Life cycle cost is the total cost. It is the purchasing cost plus operation cost minus salvage cost. We will discuss life cycle costs and life cycle assessment in detail, because life cycle impact analysis has to be discussed when we will discuss design for environment in the coming sessions. So life cycle cost and assessment would be discussed there, but some introduction to life cycle assessment would be given in this lecture as well, because we need to see what is life cycle assessment and how is our green QFD made from the life cycle assessment ratings. So next is social benchmarks. An item that turns into an accepted standard is plainly the best. Social benchmarks is, what do other considers about the item? What does other people think about the item? What is the social or the regular perception about the item, okay, or of the product that we are going to purchase? So those are also the factors which affect the voice of customer. Now voice of customer, this is the Kano model. In Kano model we have these kinds of customers. These are the items or the features which are expected. This is something that we call the primary function or the basic function. We call it primary or basic function in value engineering. Customer wouldn't say, I would buy a pen that has to write. The numerical comparison charts which I got filled from respondents, I told them that record data is the primary function. I made them to understand what is the function. In general, if you ask someone, they will say, what kind of pen? If I ask, if I ask my friend, what kind of pen you would like to purchase? He wouldn't say, I would like to purchase a pen that would write. He would say, okay, I would like to purchase a pen that is a fountain pen, that is a pen in blue color. Those things could come. This is something unspoken or expected. A pen has to write. A chair is something that has to support a normal body weight, 100 kgs weight. A bike is something that has to run on 2 wheels. So these are expected items, expectors we could say it. So these are the fundamental qualities. What are expected? These are the fundamental qualities one must offer to be focused and to stay in business. So these are the qualities that customer accept as a piece of the item or administration, that is they expect them as a standard quality but not as an add-on. Expectors are traits that are every now and again simple to quantify, and in this manner are utilized as part of benchmarking. Expectors are utilized as a part of benchmarking. Benchmarking is carried out based on these generally. These expectors are unspokens. So don't speak about this, but just expect this thing. There is something known as spokens. These are the items which the customer say that they need this thing. These are the particular entities customers say that they need in an item. These are the things which an organization would give as they speak to the parts or the item that characterize it for the customer. So, these are the also known as satisfiers or the performance features. I can put it here. These are performance features or satisfiers. So, these satisfiers are not absolutely necessary, but result in satisfaction if they are fulfilled and dissatisfaction when they are not fulfilled. The more you provide these features, the more the customer is satisfied. The organizations prioritize their efforts and put their strategies using these performance attributes as well. For instance, more efficient the service, more the customer will appreciate it. Then more promptly we get the response to an after sales service, more we would be delighted. More would be inclined towards the purchase of the product. Okay. More than the spokens are exciters. Exciters are something that delight the customers. So, these are delighters. These are certain attributes of an item that make it one of a kind and recognize it from the opposition. That is something unique in the item. Those are exciters. So, an exciter is additionally alluded as a delighter, as I said, in light of the fact that it characterizes item properties that are lovely shocks to the customer. Customer would say, wow, what a thing. So, these exciters, what we expect that green attributes can be involved. While the customers are using, they can be made to understand that they use this product and they are also contributing to the environment. So, these can also be the exciters in these days. That is what we are going to talk in green quality function deployment here. Next are unspokens. These are the attributes that the customer do not discuss, however, they are vital and can't be overlooked. It is the product development group's business to find what are the unspokens. So, this product development manager should make a utilization of market studies, customer meetings, and should conceptualize that what are the unspokens which customers expect. Now, how do the production manager or the people who decide about the design of the product use this Kano model? There are certain steps that they could follow. Number one, they brainstorm all the possible features. Brainstorm all the possible features. Using, I would say, Kano analysis. Once all the features are gathered, then brainstorm everything that can excite the customers. Identify exciters. Then we can use the Kano model to classify all the features as basic, satisfier, delighter, maybe indifferent. These are something which are indifferent, it does not make any difference. indifferent. And there is one more thing, reverse. If customers expect something, they expect the product to delight themselves, but the company is not able to do that, this acts as a reverse. So, this is reverse. Okay. Now, they put the features in the bins. Next step is they put the features in the bins. Classification. Okay. These are the bins. They put, okay, these are exciters, these are satisfiers, these are the primary function or expected one or unspokens. Now, as we did in value engineering, we said that we can eliminate the unnecessary functions. Similarly, we can cut out the indifferent features. Fourth is eliminate indifferent. Right. Now, we can make sure that the product has appropriate basic features, select the right performance features, so that the product or service can be delivered at a specific price which the customer is willing to pay. Then think how one can build some of the delighters into the product. So, next we can work in these steps. We can work with expectors, then we can think of satisfiers, then exciters which we have identified in step 2, those come here, we put the exciters here. So, this is Kano model, how voice of customer is seen. Now, regarding the voice of the customer, there are a few strategies that can be utilized to acquire the customer inclinations about the product. That is the collection of data or I can say identifying which strategy is to be utilized to see what customer wants. So, the strategy that is to be utilized depends upon the sum and the sort of the data required, the accessibility of the data, the cost designated to gather the information. So, information can be existing information or new information. Existing information is known as secondary data, new information is known as primary data. Okay, the three factors I can put here: the kind of data, next is accessibility, next is cost. These are factors on which the information is gathered. Now, existing information can be obtained from the complete sales records, including repair and replacement parts, complaints both written and verbal, warranty data, publications from the government, trade journals and the consumer, the company's designers, engineers and managers, and benchmark products. So, these are all the secondary information which is already there. We just need to clean the data and extract the required information and try to develop some knowledge out of that we can use to provide the better product to the customer. Next is new information. New information can be gathered using surveys. Surveys can be done using mail, telephone, comment cards and at the point of purchase. Then interviews both face to face and telephonic. Focus groups of the people who just talk about one product or one feature of the product. Then observation, that is using clinics and displays, using conducting experiments and watching the responses. Then field contacts using sales meetings, service calls and trade shows, direct visits with the users. So, these are the ways, some of the ways which can be used to collect the new information, that is primary information source. Next is analyzing the voice of the customer. In the wake of having recorded the voice of the customer, the product development group takes their reactions at times called verbatims and think of them as singular cards. Now, what are verbatims here? We distribute the cards to the customers and we ask them to put their perception or their feedback regarding the use of the product. Sometimes what happens, there are certain words which are similar in that verbatim. Verbatim is word to word. So these reactions are then scrubbed, which is the procedure of altering the verbatim. Sometimes there are certain words that can mean the same thing. Customer says I am happy, he can say I am elated, he can say I have enjoyed. So these words means he is happy. Okay, they can say the pen is affordable, the pen is low cost, pen is cheap in cost. That means the pen is low cost. So those words can be gathered. Then dispensing with these verbatims from different interviews that mean a similar thing. Then composing more cards for those verbatims that express more than one thought. These cards are then arranged into bunches that appear to be changed depictions of an all the more extensively communicated quality. It is conceivable that a couple of verbatims may in reality express this more elevated amount depiction. So then these cards are grouped so as to find out what is the customer wanting. So these verbatims have to be ranked in their order of importance. So there are several ways to do this, a passive way and an active way. Passive way is we count the number of times the equivalent attribute is mentioned by interviewees. Those that are mentioned the most often are assumed to be the most important. This is the passive way. Okay, this is the count, maximum number of count means more important. Active way is take those attributes that have been ranked the most important in the manner just described. Ask another group of interviewees to rank their importance. Each rank is assigned a number from either 1 to 10 or from 1 to 5, high values being the most important. Now what happens, we are collecting the data in the first phase and we are confirming that the data or the data verification happens in the second phase. That is an active way. Passive way is we collect the data in the first phase and we count the number, whatever the requirement is set by the customer, maximum number of times, that is ranked 1, and similarly we rank it 1, 2, 3, 4 and so on. We compare them with the importance ratings as well. This we will see in QFD. What is QFD? Quality function deployment. Quality function deployment is a formalized strategy for coordinating the communicated needs of the customer to the attributes and functions of an item. We have customer needs, we have attributes of item. We need to find out what are the attributes we need to work on. So this is something similar to that we have seen in decision metrics in value engineering analysis. So it is an intense technique that makes a difference to characterize the item as far as the customer's prerequisites. QFD records the relative significance to the customer of the customer requirements. Quality function deployment is converting the perceived needs of the customer to yield a competitive advantage. QFD utilizes designing attributes to portray each of the item's useful necessities. It helps in binding qualities, those are connected to the customer prerequisites. The item's engineering characteristics are additionally benchmarked to distinguish those qualities that must be coordinated and surpassed. These are known as these engineering characteristics. I will put it, these are known as target values. It is stressed that the engineering characteristics are the characteristic of the functional requirement and not the customer requirement. The engineering characteristics, I will just show you an example of QFD and we will see how QFD is constructed. I will show you the target values there. The house of quality optimizes the different parts of the customer necessities for the item and their sentiment of the contender's item. So this is the competitors products. Those are also taken into account when we discuss QFD, because what is the customer expecting from the competitor's product and would they really purchase our product, to what extent are they willing to do that. It translates and provides the judgment of the relationship of every engineering characteristic to every customer requirement. This is QFD. Now, QFD in a nutshell, I can say QFD is a multifunctional technique. Okay. Second is it demonstrates the relationship between the customer necessities and designing qualities. Between customers necessities and designing qualities. By qualities I mean designing features. So, this relation is developed. So, that this is QFD. Now, what is QFD matrix? This is the house of quality. It has certain rooms here. This is room 1, I would say, room 2, 3, 4, 5, 6, 7, 8 and 9. There are 9 rooms in this house, and this is rooftop. What are these rooms? What are the customer requirements, importance ratings, correlation metrics? What are the house and relationship metrics? I have the discussions on this, various regions of house of quality. Okay, let me first take the example. I think I will go in that way. The major features in house of quality are, we have customer requirements or weight factor in this room, which can have certain subsections. We have the engineering characteristics here. This is customer rating. Again I am telling, customer rating is how do customer rate the importance of the functions that they need, and this is engineering characteristics, that what is there, what can make the product to come into the real world. This is in grey color, we have relationship values. How is this requirement A related to the engineering characteristic 1? How is requirement B related to the engineering characteristic 1, 2, 3, 4, 5? So, this akin to the functional development worksheet that we saw. We will see how is this different and why is this the detailed version of what we saw in value engineering. Now, product ratings are here. Product ratings are the customer rating or the competitors ratings. Then we have the calculated weights, which are the importance ratings into the ratings that we have here. Now, let me come to an example, then we will discuss the QFD in detail. So, this is an example which I have picked from the QFD online website, in which they wanted to develop the chocolate chip cookies. The customer requirement and functional requirements are compared with each other. The customer demanded quality is here. Customer demanded good texture in the cookies, generous portion, good taste, low price and appetizing appearance. These are the customer requirements, those are taken, and the functional requirements can be the color that has to be given to the biscuit or the cookies, the tensile yeast strength, because biscuits are to be tested and we need to see that are they crispy or not. So, that tensile strength is an engineering characteristic here. Then tensile ultimate strength, after yield strength, what is ultimate strength? Then weight of the biscuit, then size, thickness, average hedonic scale rating, cost per cookie, density of the chocolate chips which are dispersed in the cookie to add to the taste. Now, this density and taste, good taste, should have a close relationship. Now, the relationships are given in this way. If you remember, we gave the rating from 1 to 3 in case of paired comparison method as minor, medium and major importance, difference in importance. So, in this case they have given this relationship. Strong relationship is here, then strong relationship means 9, then moderate relationship is 3, weak relationship is 1. This is what we will put in relationship matrix. Where is relationship matrix? This is our relationship matrix, this matrix. Okay. Now, the other ratings, other comparisons, we have this correlation matrix. What is correlation matrix? Correlation matrix demonstrates the level of communication among the items building qualities. These building qualities, which are color, tensile strength, tensile ultimate strength and yield strength, they should have a strong correlation. Weight, are they correlated to each other or not? Those are identified here. This rooftop of the house is the correlation matrix. For this correlation matrix, we have these notations here. Double plus is strong positive, single plus is positive correlation, negative is minus is negative correlation, and downward arrow is strong negative correlation. Also we have objectives. We will put objectives. What is the objective in this specific function? What are we going to do with this function? Are we going to improve the color? Are we going to enhance it and tensile yield strength or decrease it? We need to see. Objective is to minimize, to maximize and hit target. What are target values? We will put it here. So, these are the competitors, Mr. Fields, Mr. Girl Scouts, these are the competitors. Now, let us start putting data in this matrix, in this house of quality. So, now we have this house. In this house of quality, we have certain rooms. This room is what customer demands. This is the room for what's. What are the customer demands? So, this is our correlation matrix. Okay. These are hows. How would we have good texture? These are hows. And here we have the importance rating. Customers importance, it is written here. Okay. And this is our relationship matrix. These are the competitors' ratings. So, this is the flow diagram for the competitors' rating. What is left? We have the target or limit. Now, color, what has to be the color? What has to be the tensile strength? As I said, the requirements have to be the engineering characteristic. Okay, the target value have to be an engineering characteristics here. As I said here, so these are the target values. After target values, we have technical competitive assessment here. The target values, there is difficulty, this data is already here, difficulty to achieve the target, that is there. Then maximum relationship value in the column, that is presented here. Weight and importance, this weight is calculated here. So, this is absolute score, and this one is relative score. How we will build this matrix? Let us see. Now, some data is here. These ratings are developed by the customer. Now, maximum relationship value in a row can be 9. Relative weight is this. Weight importance is 5, 10, 25, 20, 15. This is the importance weight that is designed by the customer, and they have given for good texture from 5 to 25 this weight is given for good texture, or you can say taste good is the major priority. It is given rate 25. Okay, importance is 25. Next priority is low price. So what do you expect if you ask a customer that we are going to get you a biscuit or a cookie, they would say it has to taste good. That is the first importance. Second thing is low price. The colors and other you can say cell functions comes later. So this is third one is appetizing appearance. It should be good for health and should be appetizer. Then generous portions, then good texture. So this is the rating. Now this is the weight on importance, this is relative weight, and this can be used here. Now these are the target values. What is the color? This is specifically the code of the color. This is specific RGB code for the color, which color should be, the yield strength should be 0.1 megapascal. This is the target value, and this is 0.2 megapascal. The ultimate tensile strength, weight has to be 2 ounce. Now you can see this thing as well. These are the directions of improvement as I showed you here. Directions of improvement can be to minimize, to maximize, or to hit the target. So for tensile strength and ultimate tensile strength and yield strength, it is to hit the target, crosses the target. Weight has to be maximized, size has to be maximized, thickness has to be maximized, average hedonic scale rating has to be maximized, cost has to be minimized, density has to be maximized, density of chocolate chips has to be maximized. So these are the target values. So these are the specifications which are generally available. This is a secondary data. So might be the primary data in some of the cases, but in this case it is a secondary data which is available with the manufacturer, and let us put that data here. Now a manufacturer or the one who is designing this matrix would put the relationship values, relationship importances here. Also we have the correlations between these, the quality characteristics, the correlations. The strengths, that is the ultimate strength and yield strength, have a strong correlation. The weight and size have a strong correlation. Bigger is the size, more with the weight. Similarly, weight and thickness has a strong correlation. Negative correlation example is the size and thickness. The bigger would be the size, the lesser would be the thickness. And again negative correlation here could be, this is the size. The negative correlation is size and density of chocolate chips. If bigger is the size, lesser will be the density. This is a correlation matrix. Now we have got the customer ratings, importance ratings, the target limits, the correlation matrix. Let us move forward and get some more data or move to the next step. Next step is, we have got these relative importances. Now in relative importance, tensile strength and good texture are related to each other. Tensile yield strength and ultimate strength are both related to good texture. Then weight is related to generous portions. What is this relation? Let us come to the legend again. This means strong relationship, a circle with a dot. A vacant circle is moderate relationship, an upward arrow is weak relationship, not correlation, it is just the relationship. Please be mindful in this. So this relationship we can see here, these generous portions and weight have weak relationship, thickness and generous portions have moderate relationship. These relationships are put here. So these are all relationships. Now let us add some more data in this. Now we have got this weight importance here, weight importance. This is the maximum relationship value in column, that is 9. This is 9 value, this is 9, this is 9. This is maximum value is 1. What are these values? As we have seen in legend, these are values 9, 3 and 1. So these values are here. The maximum value is 9, 9, 9, it is 1 here maximum value, here the value should be 3, maximum value is 3. Now how have we got this rating? If you remember, like in the decision matrix that we made in value engineering, we were multiplying the performance rating with the decision value, okay, of the performance criteria, that the criteria that we selected, the cost, durability, ease of operation, there was certain ranks or certain relative importance in that with the importance value of our idea. It is similar fashion here. How do we get this value 180? This value is 180. 180 is, this value is 20 into 9. This is 20 into 9 is 180. This value, this means a vacant circle means 3. So, this is 3. 20 into 3, this value is 20 into 3. Similarly, this value 180, 60, the 60 have got, it is 6.7 into 9. 6.7 into 9 is around 60 again. Okay. So, we have got these values, these are the weight importance, these are the weight importance or absolute weight importance for the functions that we have put here, the engineering characteristics here. Now, this is a relative weight. Relative weight, you know, we have normalized all these values with 100. So, in a way we have taken percentage rating. So, we have summed up all these values in absolute rating, we have summed up these, okay, and this is 16.8 is 180 by the sum of these values, sum of row, sum of the second last row. The 5.6 is 60 by the sum of second last row, that is absolute weight or importance value row. So, this is the way we have got the absolute and relative weight. Now, this is almost complete. Our target is to get this weight. Where will you use this weight? I will just let you know. Next is, we have also put the competitors ratings. These are different competitors which are there. Their ratings are like these: 5, 4, 5, 1, 5 for these qualities which the customers have demanded. Now, for these competitors, because we need to compare, we need to benchmark our product as well, that whether the customer would buy this or not. Next is, we have developed the flow chart for the competitors rating. Let me develop one flow chart for you here. For instance, Mr. Fields, this is the first company that we are comparing with. The good texture is 5. So, first rating is, first point is 5. Second is, for generous portion it is 4. For third one it is again 5. For low price it is 1. It might be a higher price cookie that is provided by Mr. Fields, that is why the price it has got rating 1. In appetizing appearance it is again 5. So, this is the way we construct this flow diagram. So, this is for Mr. Fields. So, we have got this visual representation of the data. This is our company. Our company is this. The target is, if you can see here, this is 0 is worst, 5 is best. One has to be on the right side. On the right side. On the right side is better. So, what have we got from this house of quality? We haven't completed our quality function deployment yet. We have just converted the customer's quality to the quality characteristics. Customer's quality is good texture, generous portion, taste, cost, and the quality characteristics are color, tensile strength, then weight, size, thickness, all those things. We have got a rating for the quality characteristics here. Now, we can move further. Before that, let us have a quick glance at what are these rooms. Now, I think you know that what does these rooms mean. So, these are the rooms that we have built in this example. So, objective of the house of quality is to express the goal of the item. List of characteristics that get a rundown of the qualities of the item as characterized by the customers. Whenever possible, the customer requirements ought to be gathered at their largest. These customer requirements are additionally used to assess the applicant ideas produced to fulfill each functional requirement. Next is what are the importance ratings that we have got in the left side. Those were the customer importance ratings are weighted number required. They are doled out to the items attributes demonstrating their relative significance as showed by the customer. The difference in the color, the difference the customer think of, or the importance or the ratings that they have given to the different qualities, those were cost, color, appearance, all those things were there. The quantities required to achieve the product characteristics. These are the building qualities communicated and are quantified as far as possible. Okay, correlation matrix, which was the rooftop of the house. Correlation matrix demonstrates the level of communication among the items building qualities. It gives some thought of the level of grouping that will exist when endeavoring to fulfill the design qualities. This also demonstrates the level of grouping as often as possible realized by the physical laws representing the items designing attributes. Physical laws, we had the engineering characteristics here, but ultimate tensile, so physical law is more would be the bigger would be the size, more would the weight. So, those were the correlations that we had in correlation matrix. Next is target values. Target values for each of an item's building qualities are often decided from benchmarking information. Benchmarking information, the target values like we had competitors with us, based upon them the target values were decided. This helps to form a free evaluation of how firmly the qualities affect the item's execution traits and highlights. Next is the relationship matrix. Relationship matrix is an efficient means of recognizing the level of impact and impact between each designing trademark and the customer's necessities. This non-linear values helps in identification of those quantities having the highest absolute importance. Customer competitive assessment that we had on the right hand side in our house, it is an outline of the main a few competitive items qualities in the correlation with the item being created. On the off chance that the organization does not have a current item at the point, this customer competitive assessment demonstrates how the present items are seen by the purchasers or the customers. Next is technical competitive assessment. Technical competitive assessment, think about the competitors particulars for each of the items designing qualities to those for the proposed specifications. Each of these determinations should meet or surpass each of the contenders or the foes qualities. Now, this appraisal of the customer competitive assessment inconsequential to the customer significance rating, to the qualities that are allocated to the relationship framework and to the objective esteem sometimes. Absolute importance that we had a room at the bottom of the house. Absolute importance is the aggregate of the product of the numerical value of each element in a column of the relationship matrix with corresponding customer importance rating. It was just a product. Relative importance is these absolute importance are ranked. Relative importance is the assurance of the level of the add up to the numerical score for each engineering characteristics. High value elements here are the characteristics that are to be worked on. So, these are the rooms that we have discussed. Let us meet in the next lecture. Thank you.